All right, now let's work on removing the first item. So public void remove first. We don't need any parameters here. This one is a bit tricky. Imagine our list looks like this. 10 pointing to 20 pointing to 30. Now we want to remove the first item. So we have this field called first that is currently pointing to 10. We should have this point to the second node, and this will bring our list forward. It's going to look like this, right? However, we still have this object, this first node that is referencing the second node. So the garbage collector in Java will not be able to remove this object from the memory. To solve this problem, we need to remove this link. Now here's the tricky part. If we remove this link, we're not going to be able to set first to point to the second node, because the moment we remove this link, we lose track of the second point. So to solve this problem, we need two different references, first and second. Let me show you. So I'm going to bring this back. Let's write some code. So first we declare a variable called second. We set this to first dot next. So second is pointing to 20. Now that we have this, we can go and remove this link without worrying about losing track of the second point, because we have this second variable as a backup here. So we go and set first.next to null. This will remove this link. And finally, we need to update first and set it to point to this second node. So we set first to second. Let's test this. So back to the main class. After adding these items, let's call list.removeFirst. Just like before, we're going to run this program using the debugger. So Control and D. Look at what we have here in this list. First is pointing to the node that contains 20, and this is pointing to this other node. Beautiful. Now, what if our list is empty and we call the removeFirst method? Let's see what happens. We got an exception of type null pointer exception. This is a programming error. We shouldn't let this happen. So let's see how the built-in linked-in class in Java works, and we'll implement the same behavior in this class. So temporarily, I'm going to create another linked list. This time we're using the class that is declared in the java.util package. So we're going to create a linked list of strings. We call it x and instantiate it like this. Now we call x.removeFirst. Let's see what happens. So we got an exception, but look at the type of this exception. No such element exception. This is different from a null pointer exception. This is a deliberate error handling. So we should not be able to remove an item from an empty list. So we're going to go back to our linked list class. And before this logic, we want to add an if statement like this. If this list is empty, look, once again, we're reusing this beautiful method. So if the list is empty, we're going to throw a new no such element exception. This is the proper way to implement this method. Hey, I just wanted to let you know that when I was reviewing my videos, I noticed I made a mistake here. I didn't count for the scenario where our linked list has a single item, because this logic would work for a list that has at least two items, first and second. So here we need to add an if statement and check to see if first equals last. That means we have a single item or a single node in this list. In this situation, if you want to remove this item, we should set both these fields to null and then return, because we don't want to execute this logic over here. So see, even I make mistakes. So does everybody. It doesn't matter. What matters is that we should always review our code. We should test it with different inputs and think of various edge cases.